colleagues across the telco industry, and we published a white paper, which was now quite famous, the so-called NFV white paper, published in October 2012. And this announced the future direction for telecom networks. And that paper introduced the term network functions virtualization, or NFV, which we actually ourselves cooked up. And then we founded a body called ETSI, the European Technology Telecommunication Standards Institute, to host all of the documentation and specification work that we wanted to do. That was back in 2013. In 2014, we wanted to get the open source communities involved in what we were doing. So we founded a new open source community called Open Platform for NFV. OPNFV, probably some of you are pretty aware of it, is now merging with another organization called CNTT and is now called Anuket. So OPNFV is now transitioning to a new form. Back in 2014, you guys know Kubernetes initial release from Google, and that's why I guess I'm here, because Kubernetes then became a new way to implement software within the cloud environments, and we wanted to use that too. The first commercial NFV deployments took place in 2015, just 4 years after we brought out our white paper, and since then we've had obviously commercial deployments of NFV around the world. But ETSI NFV has been doing all of the specification work for the industry. And we've had now 3 releases of specifications, and the 4th release is now in progress. So that's really the basic concept. Main thing is we want to use industry standard hardware and run all kinds of exciting network workloads on those. But there are some points to remember about telecommunications, right? Telecom network infrastructures are not the same as enterprise IT environments. It's heavily regulated. It's massive geographic and volumetric scale, and there can be no downtime for software updates, right? So when someone's dialing 911 on their phone, you can't suddenly have that call cut off because a IT guy somewhere is doing some maintenance. So that's one of the really key things to remember about telecommunications network. The other thing about telecoms is that the services persist for many, many years. And that means that the technology itself on which the service runs is changing, but the service itself mustn't change. A good example, of course, is telephony. Making a call today is the same as it was 50 years ago. And you think, well, you know, the technology in that time has evolved, but the service hasn't evolved very much. Network operators are unique. Operations are unique to each operator and jurisdiction. So the requirements for telecoms operators in Europe are a little bit different from the US. So there isn't a one size fits all for the telecommunications environment, right? So one operator has a particular set of requirements and timescales, maybe BT in the UK. AT&T has a different set of requirements and different timescales. So this is something to bear in mind in the open source community, and I'll come back to that in a little while. Each operator must be in full control of its destiny. So we can't have a community that decides what the timescales are and tells the telecom operator what that timescales are for a release, let's say of OpenStack or something else. The operator says, no, I want that release on this day, and if I don't get it on that day, then I'll miss some of my regulatory or commercial imperatives. So telecom operators must be in control of their own destiny. And that really comes down to a key thing in telecoms, and that's standards. When people hear the word standards, they think, oh, that's a long time to take. It takes a long time to do standards. It's very slow, and it's not very innovative. That's probably true in some respects, but it's absolutely crucial to facilitate innovation because we want interoperability between all of the people that contribute technology to our networks. So one of the things that I have got here, I'm not going to go into the detail on this slide, you can read it. Comparing standards with open source. What's the difference? What's the pros and cons? Standards basically is about specifications. Open source, of course, is about code. So where does standards and open source meet? Well, first thing to say is that standards define interoperable frameworks. These are the frameworks that produce the network architectures that we want to deploy. And we want that to support software diversity. So the standard is issued as a spec, and then we want the industry to deliver to us the software solutions that support those standards. Open source, of course, I know you guys that know all about open source. You're in Kubernetes. Is absolutely critical to accelerate innovation, and especially in applications, right? So to me, open source are absolutely, and standards are absolutely complementary. It's not an either or. They're both very important in our industry. And one of the things I'd like to draw your attention to, which Raoul knows I'm passionate about, is diversity. So in all things, we want diversity. We want all kinds of viewpoints. We want all kinds of cultures to bring their ideas. And so one of the things that I've always tried to do in my career is form collaborations with different people from different places with different backgrounds. So I'm basically an international guy. I'm British, but I'm living in the United States. And I have many, many industry colleagues around the world that have become friends over time. Critical capabilities for telecommunications. So this list is something which we all hang our future credibility on, right? Designing systems that are secure by design. Retrofitting security is not a good idea. You need to actually design security right in from the very beginning. We want to basically make sure that we can assure the networks are working properly and that they're resilient. They meet the targets for availability and uptime. We want automated fault management. These are vast scale infrastructures. So we want to make sure that if anything goes wrong, we are able to detect that quickly and remedy it automatically, preferably, without any manual intervention. This all sounds really motherhood and apple pie, but these are critical things, and they're not easy to do. They're not easy to implement. And then for telecommunications, we want deterministic performance. We don't want to click on something and wait 5 seconds. Absolutely want throughput that we promised our customers. We want the latency, the delay from going one end to another end of a network, and the timing to be communicated all the way through to the endpoint. And there's this thing called jitter, which I won't go into, but it's basically the timing variations that happen in small intervals of time. And then this is something that for the open source community is very important. How do we make sure that features persist from release to release? If we fork the software, for example, into a proprietary form, has that fork got the feature that we need, that we actually implemented and required in our network? And indeed have deployed. And there's some horror stories where open source communities dropped a feature, the update was applied to the network, and then the network stopped working. All sounds pretty obvious, but these things happen. And then we want seamless software updates. I've said this once already, no downtime. And something else to bear in mind is in the commercial world, most software is licensed. Of course, there are open source licenses, and they're all present in many of the software systems that we deploy. But we must make sure that we understand what licenses are applicable and that we actually pay for those. Resilience. I'd like to make a few remarks here about resilience. First of all, software running on low-cost standard hardware can be made highly resilient, right? So I think that's probably pretty obvious for you guys. You can deploy your Kubernetes cluster on one system and have a backup in another system. And if one system goes down, you can switch over to the backup. So, and once you're in the software environment, there's lots of novel things you can do to enhance resilience. Software systems can be designed to be largely immune from multiple simultaneous hardware failures. And that's because we can do these novel redundancy schemes. A colleague of mine at NTT Docomo, for example, Tetsuya Nakamura, who's now with Amazon Web Services. Tetsuya worked on a system in Japan after the Fukushima disaster, where most of the mobile network in Japan was taken down due to overload, and he designed a resilient system based on NFV, which actually migrated the core network within 30 minutes to another data center 100 miles away. So we can have very, very large geographic redundancy using software. Some of the key issues for the telecoms industry: security. We all know about vulnerabilities. We all know about the elimination of Huawei from many countries' systems because they're Chinese. That's pretty controversial. I actually owned the relationship with Huawei when I was at BT, and they're a good company. But nonetheless, that's the perception. And so the supply chain has been damaged to some extent by perceptions of security vulnerability. There is a shortage of people in the telecoms industry with hybrid skills. We need telecoms people that can write software. We need software people that understand telecoms. And there's a big hint about future career opportunities for those of you that are thinking about your career. Telecommunications could be a good place if you've got some really good software skills, but you'll need to get some telecom knowledge. Lack of diversity of running code. If everybody's using the same code and it's hacked and there's an attack, everybody goes down. This is where software diversity is really important. And that's one of the advantages of proprietary software. Somebody's code is different from someone else's code. If everybody uses the same open source release, everybody's code is the same. The complexity of integration. That is something which I'm not going to go into here. Maybe that's a topic for another talk. But basically, bringing all these systems together, different vendors onto a common platform, is complex. And there's a question in the industry, who does that? And indeed, that's probably one of the big barriers at the moment to software migration of telecommunications networks. I'm particularly interested in the lack of diversity in the ecosystem. The problem with the ecosystem is that not too many people want to come into telecoms because the timescales for deployment are so long that there's not an ROI for many small vendors that meets their investors' requirements. All of that sounds all very nice, and there's a bunch of work that we've done in NFV that looks into resilience. So for all of you that are interested in reliability and resilience, there's some really good work there. Fault management, just say a few things about this, and I'm conscious of time. Fault management is really, really important for network operators, probably number one after security. We need to be able to deploy virtual network functions from different vendors onto a common platform and fault assure them. So good fault management requires ability to detect, filter, and correlate. And what we don't want to do is overload the infrastructure with fault management telemetry. So yes, we can instrument everything, we can monitor everything, but what happens to all of that data when it gets abstracted up to operations? So there's some very interesting work that's been going on there to try and figure out how we can use NFV to assure networks and have some novel techniques for analysis. A little bit more about resilience. We know from the hardware world that we have this thing called the bathtub curve. At the beginning of a product's lifetime, there are hardware bugs, they get ironed out, and over time, the hardware starts to deteriorate. It might be the battery in your phone, and we see this kind of end-of-life wear out. It may be surprising to know that software actually has some kinds of these features. When we're doing test and debug, we've got a lot of problems with bugs, and the software may crash, and that means it's not very reliable. As we go we shoot updates, we fix bugs, but in fixing the bugs, we introduce another bug. So you have this kind of curve where you do a software release, the software crashes because you introduced a new bug. You fix that, then you do another release, and then you get another bug. So you see this rather interesting curve. And so this is one of the things which we're concerned about in telecommunications. We want predictability. So how do we make sure that when we do software updates, we don't get an unreliable network? And there are some ways to mitigate that. And one of the things is this thing called N version programming, which is to say that we have a number of software functions that are nominally identical, but only one, if one of those is faulty, for example, or has been hacked, then we want to make sure that the others are the ones that control let's say, for example, it's controlling the aircraft. You don't want your aircraft to go down because there's a bug in the aviation system. So a number of different things that can be introduced there. This is my last but one slide. The ecosystems are very, very complex. And the first thing that happens in telecommunications is that if we want to do something completely new, like with, for example, 5G, then we get together with a bunch of other people in the industry and we have a discussion. What do we want to do, and can we converge all of our requirements? So we have a number of industry forums in telecommunications. This is a very small number of them. There are actually a lot more than this. And these guys get together and they figure out what it is they want in the future. Then they form or go to an existing standards body and they do some specification work. In the case of 5G, a lot of the specification work is done in 3GPP. In the broadband world, a lot of it was done in the broadband forum. In the Ethernet world, all those IEEE specs that you know and love, they're done in the Metro Ethernet forum and the IEEE. So those are really important. But then when it comes to actually implementation, how can we accelerate that? And this is where open source comes in really handy, because open source communities get interested in how they can make very quick progress on code. And so we have the potential for innovation in the open source communities. I've got Kubernetes up there. But also open source can be used to validate some of the specs. So some of the work going on, for example, in OpenNFV was about validation of the ETSI NFV specs. When it comes to the products, then we've got, of course, the vendors need to get involved in this because they're selling products to the end users. Let's not forget that the customers that are buying this stuff are the network operators, the telecommunications operators. And then one of the things which doesn't sometimes get neglected is, where do we get the people from? We get them from academia, we get them from the communities. And so research and new skills are being produced in academia. That's all great. And I'm just going to make a few closing remarks so that we can hand off to some Q&A if you guys have got questions. The pandemic, we're all suffering, aren't we? We're all at home, and the keynote was fascinating to me to figure out how you build communities and maintain communities while we're all locked down in our homes and in our respective countries. The exciting thing about software is you can write code anywhere. You can be anywhere and write code, and you can be anywhere and contribute code to the communities. Anybody can write code, but not everybody can write useful code, right? So what does the code do? Is it any good? Documents, and this is something which is an old bugbear for me, right? I've written a lot of software in my time, and I've had to try and figure out how somebody else's software worked. And when I opened up the source code, there was no comments, nothing, no documentation. I'd literally go through line by line and try and figure out what this software is doing. So documenting your code is very boring, but think about those who are assigned to update your code in the future. And that's something which I know is terribly boring, but critical. And then when it comes to getting a job or getting a new job, how can you stand out from the rest? This is a big question. And can you develop a coding skill that is in short supply? This is not about learning Python. This is about what do you do with the code. And so some of the examples where I think we've got shortages and opportunities for those of you that are looking towards your future career. Telecom needs software developers that understand networks. So telecom needs software developers who understand networks. So what do I mean by understanding networks? That's doing some basic telecommunications courses. This is about figuring out how routers work, how do switches work, how do telecommunications packet processors work. Software developers who understand security architectures are in very high demand. If you've got some security background and you understand security architectures, and you can teach yourself a lot of this stuff, but hopefully get some certifications as well, then there's going to be a lot of demand for your skills. And then this is particularly true in the research environment. Software developers with physics and maths. In my career, I've seen a lot of physics and mathematicians actually switch to becoming software developers, because in the end, to implement your algorithm, you needed to write some code. And who better to write the code than the guy that wrote the algorithm? So that's something which to bear in mind. And then Raoul and I, as Raoul said at the very beginning, we've been friends for a very long time, and I'm interested to explore, particularly after the pandemic, when it's becoming clear to the world that people can make useful contributions anywhere in the world, and they're every bit as good as in other places. So how can we explore how to make the talent in El Salvador and Central America available to the rest of us in the world? And I'm interested to explore that. I'm on the organizing committee of the IEEE, NFV, and SDN conference, and this is the 6th year. And last year we were fully virtual because of the pandemic in November. We were going to go to Madrid, But because we were virtual, we were able to invite papers from all over the world without the requirement for the person submitting the paper to have to travel to the conference. Travel is expensive, attending the conference is expensive. So for the first time, we had a PhD student in Panama who contributed to our conference. And that person would almost certainly not have been able to submit the paper because they couldn't afford to go to Madrid to present it. So that's it from me. There's a few useful links on the final slide. And gracias por escuchar. Thank you for listening. Over to you, Raul.
Thank you, Don. We have some questions. And I'm going to combine a couple of questions have to do with NFV, and also, let me see, CNF, Cloud Native Functions. And so the question is why? Why CNFs? And on the same question is more about like, I'm curious to the impact of containerization in terms of NFV performance, access to underlying hardware, and complex networks architectures.
Yeah, how can I say this? In cloud native functions, CNFs, are no different from virtual network functions. Virtual network functions, or VNFs, is the industry standard term in telecoms. That hasn't changed. You can't go into a telecoms environment and start talking about CNFs and say that they're different from VNFs. VNFs and CNFs are the same. But as we've gone through time, the original NFV white paper in 2012, there was no cloud native wasn't a thing. If you were a cloud person, you lived in a cloud native environment. But now that you're a telecom person, you're living in a network environment. We only understood things like virtual machines. We understood about virtual machines. And so in our estimation, you created a virtual network function within a virtual machine and everything will be great. But then over time, we realized that's very inefficient because now we can use cloud native techniques, particularly things like microservices. And so how do we now implement network functions in a cloud environment was always the intention. So the cloud guys took our concept and said, well, we don't want VNFs, we want CNFs. Well, that's completely wrong. CNFs are VNFs. VNFs are CNFs. They're interchangeable. But coming back to, I think, the second part of the question, on the useful link screen, there is a document that's been published by NFV, which talks about how VNF management can operate in a cloud-native environment. So this doesn't change the underlying concept of virtual network functions at all. It's simply that how do you efficiently implement these things in a cloud-native environment while the framework, the architectural framework of the system doesn't change. It's simply that you're implementing it using cloud-native techniques. So that's a useful place to start. And if any of you've got any questions after you read that, or you look into this topic a bit more, get in touch with me, and I can put you in touch with some of the experts that are working on virtual network functions in cloud-native environments using Kubernetes. Kubernetes is the standard way to do these things now.
Yeah. Don, please consider joining the Kubernetes Community de El Salvador LinkedIn group as well. We already have some participants there, and so that would be a good way for them to reach out to you too.
Yep, great. By all means, yeah, sure.
There are two more questions. One of them is, I would like to also hear your thoughts on Open RAN.
Okay, I like Open RAN because it's open. But Open RAN particularly is being supported very strongly by 4 global carriers, particularly European ones, who are stating clearly that Open RAN is the direction for their future radio access networks. Deutsche Telekom, Telefonica, Orange, are the three. There's a fourth one, and Vodafone. So those guys just announced 2 weeks ago that Open RAN is the future direction. So there's no question that Open RAN is an important dynamic, but there are challenges to make Open RAN to be exactly the vision that the Open RAN community wants it to be. I like Open RAN, but I think there are a lot of challenges for Open RAN to deliver the full openness vision. Because first of all, the specifications for Open RAN are not particularly well defined. And so that means that interoperability between the components, the DU, the RU, may be problematic, and operators must have interoperability. The idea that you can have an open ecosystem is fantastic, and I'm very much involved in open ecosystems. But each player in the ecosystem needs to be able to see a path to business. And I've actually put a link. This isn't in the version I sent you, Raul. At the bottom, we've got this thing called the Telecom Ecosystem Group, which I'm a co-founder. Okay. What we're trying to do there is encourage startups to come into telecoms. And it's obvious that 5G and all of the things with 5G, including Open RAN and the core network, are going to be huge opportunities for the industry. And the pandemic has only accelerated that. But the challenges remain, right? So I would say, in summary, I like Open RAN. I think there are challenges to deliver the full openness vision, unless the operators in particular take very strong action to define the interfaces and specifications so that there is interoperability between all of these entities, not just the network layer, the control layers. Hope that answers your question in a very vague way.
Great. Leonardo Murillo also wants to know the following. The role of site reliability engineering with concepts such as error budget and service level objectives in the context of telco.
What was the first part?
Your thoughts in terms of the role of SRE, which is site reliability engineering, with concepts such as error budgets and service level objectives in the context of telco.
I can't answer that. I'm not familiar enough with that domain. I can find somebody that can answer that question if you want to contact me afterwards. Okay,
thank you. There is, let me see, one more or a couple more. Let me see if it's related. So for energetic career outlook, cloud and security plus telecom combined are skills in high demand now. Would you say that is where we're heading post-pandemic? And this is Benjamin Lopez.
What was the last part of that comment, Ron?
Would you say that this is where we are heading post-pandemic, post-COVID, in terms of career objectives, whether it is cloud plus security plus telecom?
Yeah, absolutely. So no question now that most analysts now believe that the pandemic has kick-started a new era of remote working. So if you look at articles in Forbes, for example, they are talking about a significant retention of remote working as being normal. That means we need richer communications, right? Zoom and the other applications have accelerated their user friendliness. We're using Bevy, which I noticed, for example, we click backwards and forwards to the agenda. One of the issues I think that was brought up by the first keynote speaker was, how do we ensure there's serendipity? How do we interact with each other in a remote environment? For our conference last November, we tried to have a social event, and we tried to mimic people moving around the conference. For example, you've got an agenda, you click on join, right? And you can have multiple rooms. That's great, but it's still not there, is it?
Yeah.
So how can we make the experience better? That's going to require avatar, 3D environments, richer experiences. And so that is going to put more emphasis on telecommunications and also on security, right? We know Zoom, for example, was compromised at the very beginning. Some very bad things happened in Zoom. They quickly released secured encryption and waiting rooms and things like that. Just an example, we're just at the very beginning. So telecommunications operators are very much aware now that they have a big opportunity to create the mechanisms by which we can have these experiences. And I'm excited about it because we can now bring in to our industry people that live in Central America as if they're living in working in the next building, right? So this is exciting time. So yeah, I think telecoms is going to demand more software developers with the right skills. Having said that, right, the infrastructure, the wireless network or the cable network, that's not going to change overnight, right? I'm talking about most of the telecoms execs are talking about how does telecoms move up the value stack, right?
Yeah.
So we're not talking about Open RAN. We're talking about what runs over Open RAN that's not Google. It's AT&T. So they want these rich experiences to be owned by the telecoms guys, not necessarily by Facebook, Instagram, and TikTok.
Yeah.
That requires these skills to come into the industry. So I think you will see that happening.
Yeah. Thank you, Don. I know that we can, we have the privilege to continue. We can continue the conversation here. However, there is another session in progress right now about soft skills. And some of the participants probably would find that one also
great.
helpful. Yeah.
That's great. Good. Thanks.
And that was going to be in Spanish. Thank you, Dan, for sharing your knowledge, and welcome to the community. Also, you need to know that we have the community, and you can present there as well. We have meetings once a month, and so now we know where to find you.
Okay, and if it's a topic you want me to find somebody that else can talk on,
well,
then I probably know somebody that could do that. Okay, great. Gracias, and have a good day.
Yeah, please stick with that for the rest of the conference.
Yeah, I'm going to join the other group.
Thank you.
Bye.
Bye.